Hi everyone! Today we will going to explore something very interesting about electricity, how the temperature affects the resistance of a metallic conductor. Let's find out what really happens inside the metal when it's get hot. At the end of this presentation, the learner should be able to define resistance in a metallic conductor, explain the effect of temperature and resistance, describe why resistance increases as temperature rises. Now, what is a metallic conductor? It is a material, typically a metal, that allows electric charge to flow through it easily due to the presence of free electrons. Metallic conductors contain free electrons that move through a lattice of positive metal ions. Electrical resistance depends on how easily these electrons can flow. So first, a metallic conductor is it's simply a metal that allows electricity to flow easily. Why? Because metals have free electrons, tiny particles that love to move around. Now, how a conductor works. Inside the metal, electrons move around a bunch of positive metal ions. Imagine these electrons as students walking through a hallway. If the hallway is clear, they move fast. If it's crowded, well, good luck moving around quickly. Now, what is resistance? Resistance is the opposition to current flow in an electric circuit. It is the property of a metallic conductor that opposes the flow of electric current through it. It shows how hard it is for electrons to move as they pass through the metal. Resistance is like the difficulty level for electrons to move. If resistance is low, electrons zoom through easily. If it's high, they struggle and slow down. So resistance tells us how hard it is for electricity to pass. What happens when temperature increases? When temperature increases, the metal ions inside the conductor gain more energy. As a result, they vibrate more rapidly. These strong vibrations interfere with the movement of electrons. Because of this, electrons experience more collisions as they travel through the conductor. Now, here's where it gets interesting. When temperature rises, the metal ions gain energy, just like how we get more active when we're excited. These ions start shaking and vibrating faster. Now, why resistance increases? These frequent collisions slow down the electrons, making it hard for electric current to pass. Since the flow of electrons becomes restricted, the resistance of the conductor increases. This is why metals show higher resistance at higher temperatures because the internal vibrations disturb electron flow. So, what happens to the electrons trying to pass? They bump into these vibrating ions more often. More bumps means slower movement, and slower movement means higher resistance. In short, more heat, more vibration, and the more collision, the higher the resistance. Let's wrap it up. In summary, as temperature rises, atomic vibrations increases. This causes more electron collisions, which make it harder for current to pass. That is why resistance increases. The relationship is directly proportional. The temperature goes up, then resistance also goes up. So yes, temperature and resistance increases together. For most metallic conductors, resistance increases with temperature. This relationship is approximately linear over a moderate temperature range and can be described by the formula. The final resistance equals the initial resistance times 1 plus the coefficient times the temperature change, where the final resistance is the resistance at the new higher temperature T. and the initial resistance is the resistance at 0 degrees Celsius, while the A, the alpha, is the temperature coefficient of resistance at 0 degrees Celsius, and the T, delta T, is the temperature in degrees Celsius. Thank you, and that's it. I hope you learned something from this lesson.